Good morning, friends. Today we will see how to apply merge sort on an array. Merge sort is basically a sorting technique which is based upon divide and conquer. This is one of the best sorting technique as compared to the all available sorting techniques. The basic reason behind that, the complexity of merge sort remains same in all three cases. In average case, best case and worst case, the complexity remains same. It is order of n log n. As this algorithm is based upon divide and conquer, so it have three basic steps. The first step is divide. The second step is conquer. And the third step is combine. What we will do in merge sort, we first divide our array into two parts. From middle, we divide the array into two parts. Now we have two different arrays, the left array and the right array. Like suppose in this example, we are having 7 elements. So somehow it looks difficult to divide it from the mid. But we can apply the floating technique when we are dividing our array. So on the left hand side, we can have 4 elements, and in the right hand side, we can have 3 elements. It means whenever there is a odd number of elements, we will divide our array in the same way. Whenever the elements are odd, and we will divide it into two parts, so the higher number of elements will remain into the left hand side and the smaller number of elements will remain into the right hand side. So we will apply this technique on this array. That means first we will divide our array. Then what? We will divide our array till then we are having the array of 1 element. Array of 1 element. That means we will divide first array into two halves. Then each two half will divide it into further two halves. Then these 4 halves will divide it into further halves. That means now we will have 8 halves. And then 8 halves will divide it into further, then into the 16 halves. Till then we will continue this process. We find the portions of single elements. When we have the single elements in our array, we cannot further divide it into the two parts. So that is, after dividing that, we are coming on the next point of the divide and conquer technique, that is conquer. Now all single elements are sorted in itself. So there is no need to apply any kind of algorithm to conquer our problem, because each single element is sorted in itself. So when each element is sorted in itself, there is no need to apply anything on that. So now we need to apply the third important step of divide and conquer technique, that is combine. In combine, whenever we are doing that step into the merge sort, all single elements after dividing our array, we will combine them in a way that we get the sorted output. So first we will divide, then we will conquer, and in the last we will combine them. So in this example, I will show you how we can do this. So as this array, I will divide it into two parts. So this is the first part and it is having 4 elements, and it is the second half, it is having only 3 elements, 40, 30, 45 and 5. It is having 12, 90 and 10. Then this left hand side part will also divide it into the two parts, and this side will also divide it into the two parts, like this. Now it is divided into 40, 30, 45 and 5, and this half will divide it into like this, 12, 90 and 10 only. As this array already reached to a position wherever only single element is here. So it means we cannot divide this part further. But this part should be divided because it is having two elements. This part is also having two elements, and this part is also having two elements. So on these three array, the division process will remain continue, but on this array, we cannot divide it further. So let us divide this array into the two parts. It is 40, 30, and this will again divide into the two parts. 45, 5. This will divide into the two parts. 12 and 90, and this 10 cannot be divided into the two parts, so it will remain as similar in the system. Now all of these elements are divided into single array of elements. Now there is no need of the conquering because each single element is sort in itself. Now what we need to do, we need to combine them. We need to combine in a reverse order in which order the array were divided. So which two elements will combine first? So as these two elements were divided, so these two elements will combine first. So for this we will take the empty array of two elements like this, and we will apply the merge sort algorithm over here. How we will do this? Compare this element with this element, find out in which order we need to merge them. If we want to merge it into the ascending order, so we know the smaller element will come first, then later the greater element will come. So it means 30 will come here and 40 will come here. In the same way, we will merge these two elements 5 and 45. These two elements will also merge in the same way 12 and 90, and this 10 still remains same because it cannot be merged right now with any other element. Now in the next step, these the array of these two elements will merge into an array of four elements, and in this side these two array will merge into the array of three elements. If we will merge these two array, so how the algorithm will proceed? We will take a pointer for the first element of this array, and we will take another pointer for this first element of second array. If I am naming it L and I am naming it R, now look at that how it will proceed. Compare the value which is pointed by L with the value which is pointed by R and find out which one is having the smaller value. As we are finding the smaller value is pointed by R, so this value will come in this array first, and this R pointer will forward it to the next element. And again we need to compare this L pointed value with the R pointed value. That means we are comparing 30 with the 45. So as 30 is a smaller value, so 30 is coming here and L is pointed to the next value. Now again L compared with the R pointed value. So L pointed value is 40 and the R pointed value is 45. So 40 will be here and L will be reached here where no other element is available. Now, if it happens, so all other element of the second array which is pointed by either R or L will transfer into the resultant array. That means 45 will be stored. In the same way, these two array will also be merged. So the 10 will be here, then 12 and then 90. After that, these two array will merge to get the resultant array of 7 element. So we will have a pointer here, a L pointer, and we will have a pointer here, that is R pointer. Now we will compare L pointed value with the R pointed value. The L pointed value is 5 and the R pointed value is 10. So the 5 will store here and the pointer will proceed to the next element. Then 30 compared with 10, so 10 will be stored here and the pointer will move to the next element. Then 30 compared with 12, 12 will be stored here and the R pointer will move to the next element. Then 30 compared with 90, 30 will store here and the L pointer will move to here. Then 40 compared with 90, 40 will store here and pointer will move to the next element. Then 45 compared with 90, so 45 will come here and the L pointer will move to the end of the array. Then all rest of the element, if they are remaining, will stored into the resultant array. So just you look at that here, the output array is now sorted 5, 10, 12, 30, 40, 45, 90. Thank you.